A transaction pool will collect all transactions submitted by individuals in the cryptocurrency network. Then, miners will do the work of taking transactions from the pool and including them in the blockchain. So, let's create this transaction pool in the wallet directory with a file called transaction-pool.js. So go ahead and make a new file. That's transaction-pool.js. In this file, we'll create a transaction pool class with a constructor. So we'll have our constructor. The constructor won't have any parameters, but it will have a transactions attribute to represent a collection of transaction objects. So we'll set this to transactions equal to an empty array for the collection of transactions. The transaction pool will collect transaction objects in this transactions array. Other classes could push to this array directly. However, let's add a more powerful and specific method called update or add transaction to the class. We'll have update or add transaction. And this function has one parameter, the incoming transaction object. This method by default will add an incoming transaction to the transactions array. However, there is a possibility that a transaction could come in that actually already exists in the array. Well, why? Recall that we have supported the ability to update transactions with additional outputs. This means that a transaction could exist in the pool with the same ID and input. However, if it gets updated and is resubmitted to the pool, we don't want that transaction to appear as a separate transaction in the pool. We want the updated transaction to replace the original one in the pool. So to handle this, let's check if the incoming transaction already exists in the pool by using the find function on the transactions array. We're going to look for a transaction with an ID, so create a transaction with ID variable. And then this is the result of calling this .transactions.find. And then we look at one transaction object at a time, which will represent with T. And then as the actual condition, we'll make it match the incoming transaction.id. So it's going to look through each transaction object represented as T. Then as the body of the function, it looks for T IDs, in other words, individual transaction IDs that match the incoming transaction ID that is coming into the function as the parameter. So this transaction with ID variable will be identical to the transaction that already exists in the pool if it already does exist. Now, if the transaction doesn't exist in the pool, this variable will be undefined. So depending on each case, we'll update our transactions array in a different way. So first, let's check if this transaction with ID variable actually exists. In the case that the object exists, we'll find the index of this current transaction within the pool. Then we'll reset that index to the updated transaction. So we'll say this.transactions, let's access something at a specific index. And in this case, it's the .index of the transaction with ID. And then we're going to replace the transaction at that index with the incoming transaction. So this is going to change an element in the array because of the brackets indexing. And then this finds the specific index of that transaction with ID object that we found. And now we can go to the else case. In the else case, well, we know that the transaction doesn't exist in the pool yet. So we can push the incoming transaction to the transactions array. So that's this.transactions.push transaction. Perfect. That adds a way to update or add transactions to the new transaction pool class. Lastly, let's share this class as the default module. So we'll say module.exports equals transaction pool. All right, now we've completed the essential elements for the transaction pool. Let's test these features next.